Hello, my dear friends. I am Soham Jagat. Welcome you all in science class. In the chapter number 9, we are in our exercise numerical, and in last lecture we have seen example number 14. So, in this session we will start with example number 15. But before starting, I would like to say you that you all are practicing this example by yourself and practicing other numericals from different source of materials, and also revise theoretical concepts of this chapter. Then and only then you can retain this concept and grasp this concept conceptually. Okay, so I hope you do well. Example number 15. I read the data first. An object of mass 1 kg traveling in straight line with velocity 10 meter per second collide with sticks to stationary wooden block of mass 5 kg. Then they both move off together in same straight line. Calculate the total momentum just before impact and just after impact. Also calculate velocity of combined object. Okay, so let's derive data first and understand what given data is. So we have question number 15. Question number 15. Here we have two objects, so I will give object number 1 as suffix 11 and for other object I will give suffix 2. So mass of first object, that is M1, is 1 kg, traveling in a straight line with velocity, that is initial velocity, that will be 10 meter per second. So this is 10 meter per second, and stick to stationary wooden block of 5 kg. It is stick to wooden block of 5 kg. So I will write here 5 kg. Wooden block is stationary, which means initial velocity of wooden block will be 0 meter per second. Okay, by now from previous examples you know that what is stationary, what is rest position, what is come to rest. So we have u2, that is 0 meter per second. Now they stick together and we have to find initial total momentum. So I will write initial momentum as pi as well as final momentum as well as velocity after momentum we have to find. We have to find here three quantity. Which three quantity? Total momentum just before collision or say impact, total momentum after impact, and velocity after impact. So I will write total momentum before impact is equal to, what is total momentum before impact? That is momentum of first object plus momentum of second object, that is m1 u1 plus m2 u2. Now put the value of m1 u1, m2 u2. We have m1 that is 1 kg multiply u1 that is 10 meter per second plus m2 that is 5 kg multiply u2 that is 0 meter per second. So I have 10 into 1 that is 10 plus 5 into 0 that is 0. So we have total momentum before impact is equal to 10. What will be the unit? What will be the unit? Think by yourself. That is kg meter per second. Don't forget to write this unit kg meter per second and give this equation number 1 or say result number 1. Now total momentum after impact. We will have total momentum after impact. Now this both object will stick to each other, which means this object is stationary, like this is wooden block and this object is come near this object and they stick together, and now they will move combinedly. So I have m1 into v plus m2 into v. Why write only v instead of v1 and v2? Because now these both objects are combined and move together. So I write velocity as common v. So mass of object 1, I will take common v common. So I have m1 plus m2. V I take common, m1 that is 1 kg plus m2 that is I have 5 kg. So I have 5 plus 1 that is 6 v kg meter per second as result number 2. It is result number 2. Now by law of conservation of momentum, I will have, here we have to write, by law of conservation of momentum, we will have equation number 1 is equal to equation number 2, or say result 1 is equal to result 2. So I have 10 is equal to 6v. Therefore I have 10 by 6 is equal to v. It will be cut like 5 twos and 3 twos. So I have velocity after impact is 5 by 3 meter per second, and this velocity will remain same for both objects. So I have answer as velocity after impact will be 5 by 3 meter per second. Here we have one more question, that is momentum after impact. So what is momentum after impact? That is 6v. So let's put value in this equation 6v, or say result 6v. So I have to write here momentum after impact is equal to 6v. Momentum after impact is equal to 6v. So I can write here 6 multiply. What is value of v? We have v as 5 by 3. So I will write here 5 by 3. Here we will cut by 2. So we will have 5 2s are 10. So that is 10 kg meter per second as momentum just after impact. So I hope you got this point. We have used law of conservation of momentum, and after combined together they will have same velocity after impact. Let's move on to question number 16. we have data: an object of mass 100 kg is accelerated uniformly from velocity 5 meter per second to 8 meter per second in 6 seconds of time. Calculate initial and final momentum of object. Also find magnitude of force exerted on object. Very simple kind of question. We have to find momentum and we have to find force exerted on object. Let's derive data first. We have question number 16. Object of mass 100 kg. So I have to write M is equal to 100 kg. I will write here only M because we have only one object. Change in velocity 5 meter per second to 8 meter per second, which means we have two velocity. Initial velocity U, that is 5 meter per second, and final velocity, that is V, is equal to 8 meter per second. To gain this velocity, it requires 6 seconds of time. So we have T is equal to 6 seconds. Now we have to find initial and final momentum. So we have to find P initial, P final, and force, and we have to find force is equal to question mark. Remember the methodology. First, try to understand data. Read question 2 times. Read question 2 times. What is given and what we have to derive or what we have to find, and then derive given data like this, and then write what we have to find, and then after finding given data and what we have to find, think about the equations we have. Okay, so we have to find here momentum. So we have equation of momentum, that is mass into velocity. But for initial momentum, we have mass into initial velocity. Simple. Mass into velocity. But for initial momentum, we required mass into initial velocity. So we have mass is equal to 100 kg multiply velocity. Initial velocity is 5 meter per second. So we have 100 into 5, that is 500 kg meter per second. Remember, you do not need to mug up this unit. We know that this momentum is equal to mass into velocity. What is unit of mass? We know unit of mass is nothing but kg. Unit, but which unit? We are talking about SI unit, Standard International Unit. And what is unit of velocity? That is meter per second. So we will have unit of momentum is equal to kg meter per second, and also you can write it as kg meter second inverse, because this second time is in denominator. So if we write in form of multiplication, this dot is nothing but sign of multiplication. For your information, this dot is sign of multiplication. Remember that. So we have kg meter second inverse. So if I have to write it in form of multiplication. I can write as S inverse. Okay. So we have 500 kg meter per second as initial momentum. In this way we can find final momentum as Pf. So I have Pf is equal to mass into velocity. But which velocity? That is final velocity. So here I have mass will remain same, that is 100 kg, and velocity is increased to 8 meter per second. So I will write 8 meter per second. So I have answer 800 kg meter per second as final velocity. Now my dear friend, we can find force by two ways. You know the formula force by second law, that is F is equal to ma. For this we required mass and acceleration. But let me find force by definition of second law. That is, force is a rate of change of momentum. Force is rate of change of momentum. I can write it as force is equal to change of momentum, that is delta P, divide rate. Rate means division by time. What is delta P? Now you know delta P. In the previous lecture we discussed about delta P. That is P final minus P initial divide T. Now we have value of both final and initial. Final is 800, initial is 500, T we have 6 seconds. So we will have now we have Pf, we have Pi and T. So let's put value of required quantity. Pf is 800 minus Pi is 500 divide time taken is 6 seconds. So I will write 6 seconds. So I have 800 minus 500, that is 300 divide 6. So I can write is 6 5s are 13. So 5 into 0. So 5 0 50. So F is equal to 50 Newton. Don't forget to write unit in each and every quantity. So we have answer here as 50 Newton. Please write it in your fair book. This is numerical number 16. After question number 16, we have question number 17. Let's read data from textbook. Akhtar, Kiran and Rahul were riding in a motor car that was moving with high velocity on expressway when an insect hit the windshield and got stuck on the windshield. So we have three friends, Akhtar, Kiran and Rahul, riding on car with high velocity on expressway, and one insect impact onto their windshield of car. Akhtar and Kiran started pondering over the situation and they think about the situation. Kiran suggests that insect suffered greater change in momentum as compared to change in momentum of motor car. What Kiran suggests? Kiran suggests that insects suffer greater change in momentum as compared to change in momentum of motor car because the change in velocity of insect was much more than that of motor car. Akhtar said that since motor car was moving with a larger velocity, it exerted larger force on the insect. What Akhtar said? Akhtar said motor car is moving with high velocity, so it will impact more force, and as a result, insect died. Rahul, while putting an entirely new concept, and said that both motor car and insect experienced same force and change in their momentum. What Rahul said? Rahul said insect and car both experience same force. Comment on these suggestions. Here the case is that car is moving with high velocity. Here we have road. On this road, this car is moving. With high velocity. This car is moving in this direction with high velocity. Here two friends are there in car, and one insect come in the way of car. Say this is insect and hit onto this windshield. Hit onto this windshield. Now, from question and theory we studied in earlier chapter, we can say that force exerted by insect on car and force exerted by car on insect will same, which means action is equal to reaction, and that will be in opposite direction. So I can write a minus sign here. So force will be same. Force will be same. What is the formula for force? That is mass into acceleration is equal to mass into acceleration. Suppose we have m is mass of car, a is acceleration of car, m dash is mass of insect, and a dash is acceleration of insect. So force on both will be same, but mass of car is very high. Mass of car is very high, and mass of insect is negligible compared to car. So here we have less acceleration, and here we have very much more acceleration. That is, reduction in velocity will be very large. Reduction in velocity will be very large. So insect experience very high impact. Remember, force is same on both, but impact will be very high. Why impact will be very high? Because time for reduction in velocity. Here the insect have some velocity, and at this time its velocity will be 0 meter per second. This reduction in velocity will be very low. Okay, so time is very low, and you remember from the equation that time is inversely proportional to force. It means that if time in change of velocity will be very low, force will be very high. So impact on this insect will be very large as compared to car. Force will be same. So here we can say that explanation of Rahul is correct to this situation. Let's take question number 18. how much momentum will a dumbbell of mass 10 kg transfer to floor if it is fall from a height of 80 centimeter? Take its downward acceleration to be 10 meter per second. So we have one dumbbell. Let's write given data. Question number 18. Dumbbell of mass 10 kg. Height of dumbbell, that is S, is equal to 80 centimeter. Let's convert this centimeter into meter. Why? Because we have to put data in SI unit. So 80 divide 100 meter. So I have 0.8 meter. I hope you understood how 80 divide 100 came. And downward acceleration is 10 meter per second square. So I will write A is equal to 10 meter per second square, or you can write it as meter second raised to minus 2. Okay, we have to find momentum. So for momentum, I have formula P is equal to mv. So for momentum, I required mass and velocity. I have mass, but I don't have velocity. So first of all, I have to find velocity. Remember equations of motion? We have one formula like v square minus u square is equal to 2as. We have v square minus u square is equal to 2as. At starting position, this dumbbell is at rest, or say zero velocity. So I have to write here u is equal to 0 meter per second, because when we are holding this dumbbell at certain height, it has velocity 0. So we have u is equal to 0. Quickly put the data here. We have v that we have to find. So v square minus u is 0. So 0 square, that is 2. A is 10. And we have distance, that is 0.8. So 0.8. Therefore, I have v square is equal to 10 and point will be cancelled. So I have 8 into 2, that is 16. Therefore, take square root both the sides. So we have v is equal to 4 meter per second. Now we have v and mass. So put this data here. Mass is 10 kg multiply velocity is 4. So we have p is equal to 40 kg meter per second as momentum applied by dumbbell. So here we have completed our whole theory of chapter and exercise very well. So I hope you will practice this all numericals and go through this exercise time by time and revise it, because if you don't revise, it will faint. So revise it and practice it by yourself. Thank you.